Hello, welcome to the quick review for the College Board AP Computer Science A 2023 FRQ review. This one is 2 days after the exam review, so we will go quickly over the problems. I'll provide the initial answers, and they are not checked by the compiler and the data yet, but I'm just trying to provide my initial response. Hopefully this one help you to review the problem, okay? And if there's any question, let me know, okay? Thank you. So let's get started with problem 1. So let's get started, okay? So here we have the problem 1. And the problem, this question is regarding the appointment book class, which provide method for students to schedule appointment for their teachers. Appointment scheduled during one of the A class period during the day, okay, whatever. Let's look at the next part. So appointment book is like this. Here is minute free, period, and minute. Okay, so period is from 1 to 8. Minute actually 0 to 59. Okay, so if minute in the period is valid for appointment, return well, it's available, it's true, return true. If not, okay, return false. Okay, so here we have if limits free, okay. And then we have the reserve block, okay. So reserve block of minutes start with start minutes in period and its duration period with a certain minutes long for the appointment. Reserve block, okay, there is a period and start minutes and duration. So basically, right now we have a rough picture of this. There are A period, and then each period you may have a certain starting time and ending time. This is actually the reserve block. You may want to reserve a certain time, some duration. Okay, and you can actually check a certain night whether it's actually free for reservation or not. So basically, this problem is something like this, and then it will involve the modulation. That's my impression. So let's go back. So basically, so far it's actually is minute free, and then we have reserve block, and then the duration will be within 60 minutes. So it will be overlapped at most 2 blocks, okay? And then there's a search, the first block of duration, time, okay, whatever. Okay, now the part A search for the first block of the duration, 3 minutes during the duration described in part A. Return the first minutes in the block of such a block is fine. Return -1 if no block is found. So there's a period and then duration, and then find a free block. Okay, so you actually have a period, and then okay, find the first block of the duration free time during period described in part A, and return first minutes. Okay, if first minute in the blocks, if such a block is found. Okay, that's part A, and then the part B. Okay, let's look at this one. So part A, find a free block which search for period for first block of the free time. So basically 0 to 9 is 10 minutes available. Okay, so every block is 10 minutes, 5 minutes, okay, whatever. Okay, so this one, 5 free block. So 5 free block, period 2 for 15 minutes, you return 30, indicate that the first, that a 15 minutes block starting with 30 minutes is available. So this one meaning that finding free block in period 2, and then it actually will have it will actually have 15 minutes block, and then this 15-minute block, the first available time will be 30, starting with 30 minutes. So, okay, so that's and no step should be taken as a result of the call to free block. Mark this 15 block unavailable. Okay, so this one meaning that whether there's a multiple block. Okay, so based on this one, okay, so if you find actually your 0 to 14 is not available, okay, so find the first in period 2, 15 minutes. Here, okay, here you need to know, okay, so it's actually from 15 to 29 is not available. So 30 to 34, this is 15, but this is available. So return 30, this one. Okay, finding 2 and 9, it will also, okay, this one is only 5 minutes available. This one actually is 15 minutes available. So here you will return 30. So 20 minutes block, there is no available in period 2. Okay, so this one is the 5 free time. So let's actually go back to, okay, so this one is a certain period, so certain time, whether it's available. So let's go back to the function available. The function available is there is minute free, so that the certain time you check the certain minute. So reader block, you will read a certain block, okay, and then 5 week. Okay, so this one 5 is 3-minute block. You will check calling. You will be calling is a minute free or not. Okay. So basically, you can use the is minute free or not to create a certain available list for the 60 minutes. That would be a better way to solve it. Okay, so let's look at this one. This one. Okay, this one. Let's look at this one. Find free block. Okay, so they find free block. You are getting this period and duration, and you need to actually call a function of is minute free. Okay, in the current period and actually minute. Okay. So let's see. So we actually will get started with this function. So let me actually copy this function over. Okay. Okay, I'm sorry, it cannot be copied. Let me actually just write it. Okay. So we have public integer find free block. Okay. Integer period. Okay. Integer duration. So what we can do is that here we can create a, because it's minutes free, we can create a Boolean array. So since we are testing on a certain period, okay, certain period. So basically we check every minute in the period first. Okay, so basically using this one, we call it's minute free and then the period. To check that period and every minute, so we check I. Okay, then we will set up the array to be for every minute in that period. Okay, now when that is done, next one we are going to check for the duration whether it's fine the first minute that's okay or not. So for integer I equal 0, I less than 60 minus duration increase. Okay, so 60 minus duration actually plus 1. Let's actually check it. Okay, check the index. So basically here you have 60 minutes. 60 is over here. Okay, and so that's here we have duration. So this one is 60 minus duration. So this unavailable one is 60 minus duration plus 1. So its I should be less than this one. Okay, this is the last window we would check for the duration length of minutes, whether it's available or not. Okay, so this one we go into the function and we check every duration whether they are available or not. Okay, so here, okay, here we need to check every minute. Okay, and then we say Boolean available equal true. Okay, if that minute is not available, a certain minute is available between I plus J, okay, is not available, then available equals false. Okay, get out of here if available, and then return. You will return return what? Return I. Okay. If not, you return -1 because you cannot find any free block. Okay, so this one is our solution for question 1A. Okay, let's look at question 1B. So 1A, find a free block, we get it. Okay, find 1B. So make appointment period, which will search for the period from start period to ending period inclusively. Find the earliest block of duration available of minutes in the lowest numbers period. Okay, lower numbers period is such a block from make appointment will call a helper reserve block to mark the minutes in the block unavailable if true. If okay, whatever. So this one you will have something that is. So you're going to make appointment for 2422. So let's look at the 2422, the parameters. Okay. So 2422 is starting period, ending period, and duration. So basically, you want the starting of the 2 and then ending at 4 for 22 minutes, continuous 22 minutes. So you start to look at this one and you return, okay, the result in minutes 5 through 26. Two not available, 5 to 29 available, okay. So basically this one not enough. So return, let's see. Return true result in minute 5 to 26 inclusive. Okay, 3, 4 true result in little minutes to 2. Let's see, here this problem actually write appointment search period, starting period to ending period inclusive in the earliest block available duration available units in the lowest number period. If such block is found, make appointment, call the helper function reserve block. Okay, let's see reserve block. So reserve block is reserve certain period and starting minutes and certain duration. Okay, so this one is needed by the make appointment. Make appointment starting from certain starting period and ending period for a certain duration. So let's see here. Okay, write a make appointment method which is search the period from starting period to end period. Okay, find the earliest block duration available in minutes in the lowest number of block. If block is found, make appointment, call the helper. So you check every single one, 2 to 4 for 22 minutes. 2 to 4. This one you have 20 minutes here, you have this one, 32 minutes, you have this one available. Okay, you also have, no, you have this one available. Okay, you have this one available. Okay, so basically you check every block and for the available minutes, and then you make appointment. Okay, so the function actually will return true or false. Okay, and you starting from the starting period and ending period. Okay, so this one, let's actually copy it over public Boolean. Okay, make appointment integer start period and then integer end period. Okay, and then integer duration. So basically this one default will return false. Okay, and then for integer I equals start period I less than equal to end period. I increase. Okay, now we check. Okay. We need to check 5 free block, okay? So So 5 free block, we check every period for the duration. Okay, we got the minutes, okay? And then if minutes greater than 0, not minus 1, we find certain minutes with that block, so we will make reservation. So you need to call the make reservation function reserve block. Okay. And if we miss, then that period do not have the time, okay? And this one, we will return true in this case, okay? So this is a part B. So you actually, from starting period to ending period, and then for each period, you try to find the free block. If there's no such a free block, then we try next period, okay? If there's a certain free block, then we actually reserve that free block for that duration and return true. And if at the end we cannot make any free block, then we actually return false. Okay? Let's check overall. Verbally scanning it. Don't have typing error. Okay? Okay. That's it. Now I'm going to work in on question 2. Question 2 is a class building problem. This question involves a method to distribute text across the line or electrical sign. So here we have 15 character per line, okay, and then the message over there. Okay, this is the problem. So it is a class problem, and it will involve the character and string. Okay, so string constructor has 2 parameters. First parameter, string that contain the message to display. Second is the integer, the width of the class. So let's actually get started with this limited information. So this is a Q2. Okay, class. Okay, the class name, let's see, equals sign class. So let's get started with this. And then constructor have 2 variables, so sign. Okay, here we have a string message. And then integer text per line. Okay, so that's actually called length. Okay, let's call it length. Okay, this portion I will be tapping to the middle. Okay, so here I might have a private, okay, string message. Okay, private integer. Okay, length. Okay, and I assign this that msg equal to msg this that len equal len. So far is the length and message the parameters. Okay, so the width of the maximum number of characters displayed per line of the sign. The sign contains as many lines necessary to display. Okay, and the message is split among the lines of sign without regarding to the space or punctuation. The only last line may contain fewer than character than. Okay, so here we have such information, whatever. Okay. In addition to the constructor have two methods, so that's actually included two methods. One function is the number of line. Okay, return integer. And then representing the number of line needed to display the text in the sign. Okay, so this one will return 3, 2, 1 respectively in the table. Okay, this one is easy. So here we have this. Okay, that's actually in integer counter equal 0. Okay, and then actually return counter. Okay, so while actually str the length. Let's see here. Let's actually create a string. String s1 equals a new string. Let's create a new string using the MSG. Okay, so this one will not change the content for MSG. Okay, so here while s1 the length greater than 0. Okay, so here s1 that call s1 the substring of the length. Okay, you chop off the length number. Okay, and then C++. So basically, you have a certain string, you chop off length, chop off length, chop off length. Okay. So in this case, you will have okay 1, 2, 3, 4. Okay. So this one originally is a length, first time go in, length go in, length go in, remainder go in. Okay. Here is a problem of this substring length maybe empty string. That actually should be fine. It will give you the empty string. Okay. You will not have the index out of bound. Let's see. Okay, let's do this. Okay. This one actually only do this if actually S1 the length greater than the length. Okay. Equal, you don't do this. Okay, the equal that's greater equal. Okay, equal is also okay. Equal, you will trump up the last one and then you will not advance anymore. Okay. So this one will prevent it to trump up to too long. Okay. Trump up too long. So this one is okay so far. So this one is the first function. Second function is get line. So broken into line or separate semicolon. and string by the get line. Okay. So this one part B called get lines. Okay, so A here you will have this. So you will have trumping, and then here you should end in with a semicolon here. Okay, even the last one you will get the ending. Okay, no, the last one won't. Okay, the last one won't. The last one you won't get it. So actually is in between when you have it. Okay, so this one is similar to the function that we are trying to do here. Okay, so let's actually get started again. So let's do string S1 because we don't want to change the content of MSG. Okay, equals new string here MSG. Okay, and then besides that, you need to have a string return equals empty string. At the very end, you will return the R. Okay, so here while S1 length greater equal 0, to the following. Okay, greater than 0. Okay, equal 0, you don't return. Okay, so here, okay, here you also need to have Boolean. Okay, first. Okay, you first we do this. Okay, we do R plus equals to str the S1 the substring of 0 to length else R plus equal to S1 the substring of okay, this one, the previous problem, we should guarantee it to be empty if actually, okay, something like that, okay. Okay, so here we do this. So this one, we would have to do if that ends. Put it equal to length. Then we do R plus equal to S1 plus substring of 0 to length. Okay, let's review this one. Get lines, okay, you get started with the R equals MP string, and your S1 is using the message. So while first equals true, okay, you actually started with the first equals true. If the S1, the length greater than 0, you still have some message. You go into here, if it's the first time, then R plus equals str the length, okay? And then this one, okay, this one you still need to be careful, okay? You need to check the length, okay? You need to check the length. Okay, so that's actually, here is a little complicated, okay? So if a first, then actually do this, another way do this, okay? So this one let's actually modify it a little bit, okay? So while loop is up to here, let's actually do this, okay? Okay, so this one actually use the trunk of to be here, okay? So basically, the if first part only handle with the rest part. So let's actually make it shorter, okay? Make it shorter. Okay, and this portion let's actually copy to here. Okay, let's actually change a different way, okay? This actually may be a little bit too early, so let's do if not first. Okay. R plus equals the semicolon first. Okay. Then we don't need to worry about it. Okay. Okay. And then this portion we just need to keep this portion. Okay. To add the tail part. Okay. And then here you add it first. Actually equals not first. Okay. So this one, let's see. R equals empty string, and you actually start with S1. So if S1 greater than 0, if actually it's not first occurrence, you add in the semicolon, okay? And you check the length of the string, okay? And you modify, you add this, okay? Okay. Okay, so right here we can further modify this one to put S1 equals S1 plus substring LEN. Okay, else portion we set S1 to be empty string, and we can save this portion. Okay. So you start with empty string, and then every time, if you are not the first, you add with a semicolon. If it's and every one you truncate the length, okay, and then you add the substring of the length, convert it to the substring of the length, okay, and then remainder of the string if it's less than the length, and then you convert it to be this, okay. Okay, so this one actually is the problem 2. Now let's look at problem 3. Okay, problem 3. This question involves analysis of weather data. The following weather data have an instance of available temperatures. So here we have weather data, and it's already sub double temperatures, and temperature is already sub doubles, and then clean data. Okay, long wave of heat. Okay, with a threshold. Okay, let's look at problem part A. Write a clean data measure, okay, which modify the temperature instance variable by removing all value that is then lower. So we do have such a temperature, and we want to remove the measure by clean data, remove clean data 85, 125, 120. So someone lower than 85 and higher than 120 will be removed. So after removal, it will be like this. So this one is a lower and upper cleaning data type problem. Okay, this one is pretty easy. Okay, so let's get started. Okay, let's get started with this problem. So copy over public void clean data double lower and double upper. Okay. This one is a removal inside the array problem, so you need to take care of the index, okay? And you can do it by backward traversal or forward traversal with advancing the right index. So this one I'm choosing to advance the right index part, okay? So I'm going to use okay, the array list. The array list is called temperature. I increase will not be included. Okay, so let's make it this way. Okay. So let's do this way. So if actually temperature, okay, temperature is actually double already. So get. Okay, so let's do this. Let's actually have a double. Temperature equals temperatures that get I. Okay. If actually T less than equal to lower for t greater equal to this one actually upper, okay. Then temperature remove I, okay, else I increase. Okay. So this one is the best solution for the answer. So this one is Q3A, Q3 part A. Okay. Now let's look at part B. Okay. This one is simple removal of the element problem. Okay. In array list, but you need to take care of the advancing of the index. Okay. Part B, the long heat wave. Okay, so here, return the length of longest heat wave found in temperature that with a certain threshold. Okay, and here is the at least one heat wave in temperature based on the threshold. Okay, that's integer. Integer is the length of the longest wave temperature. So this one, okay. This one, your longest threshold, okay, so you need to find out here, you have the longest temperature, right? A certain heat wave of certain length. Okay, so certainly, so you actually try to find from the size down to 1, okay, down to 2, okay. Default, you will return 1. So here, let's see, is there any function that you can use? No, there's no function that you can use. Okay, there's no function that you can use. So you need to find the longest wavelength. This one, this problem actually, you need to start to find, okay, you need to start to find from the whole, from if the longest one actually is everything, okay, then the second longest one is 1 less, okay. Second longest one would actually is 3 possibility, okay. Until up to 2, okay. Until up to 2. So let's do this, okay. So let's actually try this way. So the longest possible is actually max, okay. And then return 1, okay. Minimum is 1. So while, okay, max greater equals 2, okay, you continue to do this, okay. And then at the end, max decrease, okay. Max will increase by 1. So now you have a maximum, and then you need to go through every possible one. So your max is actually the window size. So for integer I, integer I equal 0, okay, I less than the max, okay, I'm sorry. Here, let's actually do integer s size equals temperature size, okay. And this one, that's assign size to max, okay. So starting from this. So here we would have I less than size minus max. Max is the windows, okay. I is the starting index of the, okay, of the window, okay. Okay, this one is look at it, okay. So your temperatures, total size of the array list is the size. Your maximum, you starting with the size. Okay, so the whole thing. And then every time your max would decrease. So from the whole thing, then second time it would be max minus 1. Okay, but you would have these two cases. So max is also the window size. Okay, and then you check every possible window size, possible window. And in the window, you actually set the uh, longest continuous heat to be true, okay? And then if the temperature less than the threshold, then the continue will become false. Otherwise, if you check everything is all true, then you return the current maximum value, okay? So this is the longest heat calculation, okay? Okay, that's this one actually is one of the coding bad problem, okay? Now let's look at problem 4, okay? Problem 4, we have a piece of candy in the box. A candy class represents single piece of candy, okay, whatever, there's a gap flavor. I think this looks like an interface, okay? So there's a box of candy. So there's a two-dimensional array with the candies. It's row and column. Okay, so Boolean function. Okay, move candy to the first row, whatever the column. So move the piece of candy in column. Okay, if necessary and possible, so that the box row zeros or column contain a piece of candy as described in part A. Return false if no piece of candy in column. Return true and return true otherwise. Okay. So here we have a candy of a box and then move piece of candy in column if necessary and possible. So the box of row zero and the column contain a piece of candy as equals to part A. So let's look at part A. Okay, this is not clear. So here, move candy to first row. Okay. And then which attempt to ensure the box element at row zero and column contain a piece of candy using the first step. If the element in row zero column already contain a piece of candy, then the box is unchanged. And the method returns true. Okay. If the row and column do not contain a piece of candy, then the method search for the remaining row of column list. Okay. If a piece of candy can be found, then move it to row zero. And the previous location is set to null. Okay. And return true, otherwise return false. Okay. This algorithm not too hard. So here, let's see. Move candy first row. It'll return false. If your column does not have a piece, okay. One, then you will return true because the box element already a piece of candy remain unchanged. And then move the row 2. This one move the 2 piece. Okay. This one you will move the cherry to it or grape to it. Okay, this one not really hard. So let's get started. Okay, either one is fine. Okay, they don't say which one need to be removed. Okay, so now let's get started. Okay, so you need to go. Actually, it's only a column traversal. So let's do for integer r equals 0, r less than. Okay, let's work on this. Okay. So this one, let's actually work on it. Okay. So if actually the candy is a list. Okay. So box. Okay, it's called box. So if box row 0 and the column equals null. Okay, now equals null. Okay, so now equal null, then we will return true, no change. Okay, we return true, we return true, and nothing will be changed. Okay, otherwise we'll traverse through every row. So starting from row equals 1, okay, and then row less than, okay, at the very end we will return false, okay, if not found. Okay, so row less than the column, so it is box, the box that length and row increase. Okay, so if the box row and the column not equals null, we will do the following: we will do swap. So it will be candy temp equals to box 0 column box 0 column equals box row column, and then finally box. This is a simple swap algorithm. Column equal temp. Okay. You still need to return true. Okay. So this one's pretty easy. Okay. Pretty easy. Okay, this is a Q4A. Okay, let's look at Q4B. Q4B is removed next by flavor. Okay. So a box, return box and return a piece of candy with flavor specified by the parameter. Return with no such piece. Okay, let's look at it. So part B, attempt to remove and return one piece of candy from the box. This is to be removed from the first beacon in the flavor equal to the list. It's encounter traverse box. For the last row box. The last row box traverse from left to the right. Then the next to the last row box traverse from left to the right. Okay, so basically from here to here to here. Okay, so it actually is row major and then a large row to small row and small column to large column. Okay, if not found, okay, remove the candy will be desired flavor. Okay, so you so here let's look at the example. So here we remove cherry and it return cherry at row 2, column 0. Okay, and this one become null. Okay, it is successfully found. Okay, and then here it actually if actually try to remove line, then it will be line, first line is over here, okay? So that one will be removed, okay? That one will be removed. And if you remove grape, no grape in there, okay? So this one is a pretty two-dimensional traversal, but from large index to small index. So Q4B Okay, Bakassi is a candy type, and you need to check the flavor, okay? So flavor is a string. So there's a function called get flavor, okay? Okay, so you actually set, I'm sorry, RC to be null, and then return your flavor. Okay, if you found a flavor that matching it, you get the candy type, and then you set the path to be null, and then return it. And then if you cannot find it, and then you return null at the end. Okay, thank you. Bye now.